Welcome to my poorly named talk. I wrote this title to try and encourage the idea that what I wanted to do was, as a programmer, write stuff for designers that meant that they could get things from brain to game as soon as possible. And thus, they would spend less time interfacing with me and more time focusing on their craft. That's what this talk's going to be about and how we enabled it at RocketWerkz. So firstly, who am I to be talking to you like this? I'm a developer. I've worked in the games industry for quite a while now. I was one of the original members on Ashen, who was working out of the Featherston house, eating quiches from the dairy down the road and freezing ourselves with tarps as light blinders. I used to be a lecturer at Media Design School, and as a quick touch, I've seen a bunch of my students here, and I was a small touchstone on their journey as developers, but it's super awesome to see you guys where you are now, and it makes me super proud. So just wanted to say that. Other than that, I wrote a textbook on Unreal Engine. I worked at an AI studio being the rendering engineer in TechRat, making real people, digital people. Thankfully, I left that job because Unreal would have put me out of a job about 2 months ago when they released their digital person suite. But that is awesome, by the way. I strongly recommend checking it out. Outside of that, I'm the tech lead at RocketWerkz in Auckland, which is quite cool. Dean gave me the opportunity to grow and start a tech team from scratch, which gave me the unique position to be able to enact some of my dreams around how I wanted designers and technical people to work together. Other than that, I'm a dungeon master, and I'm full of stoke again after hearing all the awesome RPG chats we've had here so far. I'm a surfer, love surfing, it's awesome being in the water, and disc golf has been my latest obsession, and I actually do that more than anything else now. I'd strongly recommend it. There's a New Zealand brand called RPM that let you throw kiwi birds, like piwaka wakas and kiddadoos and stuff, so it's awesome. The other thing I do with my friends is we make rum. We try to sell it, but we drink it first, which kind of sucks. And as some of my students know, I talk fast when I get excited, and I get excited easily. And someone's given me a laser pointer. Also, if anyone wants to reach out to me, I love to get words from you guys. If you have any questions, anyone who's about to work with Unreal Engine or in general about to do some new tech stuff, please feel free to reach out. I'll do my best. I get a lot of emails, but I'll try and sort things through so I can get back to you guys. So, as I said, I'm at RocketWerkz right now. For those of you who don't know, RocketWerkz started in Dunedin about 6 or 7 years ago, focusing on cool indie projects and kind of experimental business practices and structures. And then about 2 years ago, Dean was like, I want to move to Auckland, and I want to make a new studio, and I want to make a AAA game. And he was like, hey, Ben, you know programmers? You can make code, right? Do you want to do it? Thankfully, he got in touch with Stephen Knightley, who's a legend and an awesome contributor to the game scene in New Zealand. And with our powers combined, we managed to start and grow what is RocketWerkz Auckland. So RocketWerkz has put out some awesome products so far already. Stationairs is described by the lead of that team and a bunch of other people as nerdy Minecraft. And I can't agree more. You have to worry about oxygen density around your engines or your base explodes, which is kind of cool. Next thing they made is Out of Ammo, which was a product of a bunch of, interns and juniors, and they're like, here's a VR headset, have fun. And then they came out of a room with RocketWerkz' first profitable product. So, that's kind of awesome. It's a great VR game. If you do have a VR headset and you want to play like a pseudo tower defense shooty, that's the one. I'm here to mainly talk about Icarus, though. Icarus is our big new endeavor at RocketWerkz. It's the whole reason we've created this massive team in Auckland, and we've got Laurie on board doing awesome community outreach. And because we want to make this new AAA survival experience, and it's a super motivated product for us. Dean's kind of really coming to the table again for the survival genre in the first time, so he doesn't want to screw it up. And this is what we're going to do. So Icarus is going to be a massive world game, which is awesome. Survival games, have a really close relationship with the environment that you play them in. Given that survival is all about versing the environment, that's the thing we want to really dive into with Icarus. A lot of survival games, there's lots of PvP and other conflicts, but I think you almost lose sight of what survival is in the real world. And having Dean had climb Mount Everest and go to the South Pole or the North Pole, I don't know, we had a satellite phone call meeting once, and it was kind of weird. He was like, hello, could you please do the thing? Over. It was like super strange. So with all of that inspiration, we can make the environment super visceral and deadly. It's the weather that should be killing you, the environment, the lack of food. We wanted to release it at AAA. I'm a fan of survival games, and there are some really great polished survival games that come out, and there are also ones that don't come out polished. I'm sure you've all seen early access survival games that are super janky and very buggy. We wanted to try and make sure that Icarus came out super good straight away. It's going to be continuous service. Icarus is going to hopefully be around for a long time, and that means we want to keep making content for it. We want to keep updating it. We want to put new things in. We want design to keep coming up with new great ideas all the time for years. And the other thing is that we've got kind of two phases for the game. There's this HAB concept where you're in an orbital station, developing your player, doing long-term progression, and then we've got the planetary game, which is where you go and actually survive, break down things, hunt deer, and all that stuff. So what we have here is kind of like a massive content issue. Oh, sorry, that's a secret. We have a massive content issue. We're looking at a huge continuous service game that's going to be a massive open world that's going to need lots of updates and lots of really cool items and stuff to do for the player in that space. So we've got a massive world, and one thing that we've tried to really embrace is making sure that everything you see you can kind of touch and do stuff with. You can cut down every tree, you can pick up every bush, you can interact with berries, you can shoot deer, you can drink the water, there's fish in there that you can hit. And so already we're starting to talk about a lot of like really crazy systems that are starting to interact with each other. Here's some people having fun in that world, hunting deer with a dropship in the background. Here's someone having not such a great time in that world. It's one thing to make a beautiful and interactive world, but you've got to make it matter to the player. You've got to make sure that when they are engaging, there's threat and there's concern. And you want to make sure that when you've got this huge system and simulation, that your designers don't have to worry about blowing things up when they want to make value changes. When they want to make something slightly more pressing or slightly more threat-inducing, that should be the only thing they're concerned with, not changing this is going to make everything collapse. We're making this in Unreal Engine. Everyone, show of hands who's working with Unreal Engine or has worked with Unreal Engine. Yep, awesome. It's a great engine. It's got a lot of pros and cons. More pros than cons, which is why everyone's using it. One of the ones that I'd like to point out here is that it's got a massive set of cutting-edge features. Like never before have we had such a democratization of advanced game technology. We can get our hands on really cool new, like Control Rig comes out, and then all of a sudden there's a new particle effects system called Niagara, and then there's like new multiplayer stuff, and every 3 months there's something amazing coming out from that engine. And I think internally, as an in-house development studio, unless you have specific knowledge of what you need, you can't keep up. Just like I said before, I would be out of a job at Cell Machines because, a year and a half spent making digital people, and then Unreal goes, oh, we did it with 5,000 people. Like, okay. The other thing is Epic are cool. Epic gets a bad rap on, the games community for the way that they're handling their store, and the game developers community, the game consumers community. But Epic are releasing free tools for us all the time. They've released Epic Online Services, which is like a platform for you to be able to have, if you want to make a multiplayer game, you need to worry about accounts and data storage and analytics and all these things that you don't think about when you want to make a cool interactive multiplayer game. They're like, here's a free package that kind of does that for you, and lets us have all those tools for free. So Epic are awesome. The cons though, and everyone who put up their hand before, I'm fairly certain you'll be used to these, blueprints can explode on you. You can have designers do a bunch of work in blueprints and they can't merge because they're binary. That leads to lots of anger because all of a sudden weeks of work or maybe a lot of different value changes everywhere just blows up on people, and it can cause a whole bunch of contention. Also Blueprint can turn into spaghetti, like just really easy. If you've got someone who's trying to hack something together for a deadline, all of a sudden you've got this massive, unmaintainable blueprint, which is called your player character, and it's fundamental to the game, and everything starts getting crazy. And upgrading engine used to be a big challenge. It's gotten better, but with combination with those blueprint issues and huge monolithic blueprints, it can also blow up in your face. And our janitors are required. All of that stuff I just talked about, you need to have someone dedicated to clean that stuff up, maintaining it. Even just renaming and moving an asset in Unreal can lead to, I see people laughing because they've experienced this before. Like, I just moved in the mesh, what could happen? And the build explodes, and it's like, oh my God. And that kind of leads to the purpose of this talk for me. Unreal is this huge tool, and it's super powerful, but you can quickly get wrapped up in problems that aren't your concern, that shouldn't be your concern. Brain to game is what I like to say when it comes for design. They should be thinking about how creative they need to be, know what tools they can use, and be really concerned with that problem. They've got to deal with making the game fun already. I don't want to have to make them deal with making sure they don't put the variable in the wrong place or call the wrong reference or update something incorrectly. So we had an interesting problem in front of us. We needed to create a network of things that needed to be scalable so that we could create a whole bunch of things. We wanted it to be maintainable so designers could easily read and find where to make updates and make little design cuts. And the last thing is we needed it to be mergeable. As you guys know, rapid content iteration does require lots of paralleled development, and that means you need lots of merging. And Unreal didn't like to do that a lot. So we had to come up with a solution for this. One of the solutions that we looked at, and more importantly, needs to make our designers happy. Sorry, that's the key point. All of our technical discussions that whenever we did sit down for our huge architecture discussions or how we're going to make Icarus, it always came back to that same statement. How do designers work with this? What are designers going to do with this? And not even just designers. What are artists going to do? What's our audio team going to do? The people who are actually creating the content for the game, developers and programmers, you enable them. And I believe that so strongly, that as a developer, you make games, but what you're really doing is making tool sets for other people to make games. Sometimes you get to make cool things when the project's smaller, but in larger scope things, you have to kind of relinquish some of that game tinkering yourself and focus on making sure that your great team can do the best work. And then you can start making cool stuff, because if they can use it, you can certainly use it too. So one solution we looked at was the game playability system, and I know Keegan did a workshop on the game playability system earlier this week, and that's awesome. So about a year and a half ago, or 18 months ago, when I first kind of incepting what our solution was going to be, this was really new. Not a lot of people had used it yet. There wasn't a lot of documentation out there. It was really hard to find experts. Every person that we talked to that was a technical designer were like, have you used the game playability system? And there's always this kind of like, I've seen the document. No. And it's really cool. The game playability system fills out effectively the ability to do this. You can create a network of things. You can create a bunch of interrelated code pieces that know about each other with non-binding ways, like through tags or easy lookups. It's scalable. The whole idea for the game playability system is to create lots of abilities and have them all kind of interact with each other and do cool things. And it's maintainable. You can reuse generic pieces for refactoring. Unfortunately, though, as we started to dig into it, we found some more problems. It can quickly become convoluted and hard to track down where all your network of things is. Obviously, that can be mitigated with good folder management and good structure, but even those great practices can slip sometimes. If you're in the middle of crunch or if there's lots of deadlines, people just start chucking things in the game, and combined with the renaming and moving thing I talked about just before, things can blow up really easily. It's scalable, but it did require technical designers to use, like quite technical designers, people who had experience with gas, and it was hard to find experts. So obviously, Unreal is doing a great job of trying to fix this, and I really think the game playability system is something that everyone should look into and watch it grow, because it'll be a huge tool. But the last problem is it still has a binary asset dependency, which means that the data assets that you use, the things that end up coming together, still don't merge very well. It's easier, certainly, but it doesn't provide that kind of whole-scale solution that we wanted to get our hands on. This is when we came up with a trait system. So the trait system was our ability to think, okay, if we take gas as an example and what it's trying to achieve, and we want to try and apply it to a wider range of things, because gas was great for making stuff do things, but not necessarily telling you about what a thing has about it. How tall it is, whether it can explode, how wet it is, how conductive it is, all those things. So we came up with a trait system. In essence, the trait system is what your thing can do. Can you action it? Can you pick it up? Can you set it on fire? Does it conduct electricity? Does it explode? All those. Can you throw it? What's another one we have? Oh, can it transmute from one thing into another? And what is its byproduct? And that also let us as developers sit down and think, okay, if something's actionable, what will designers really want to fill out? Do they want to fill out how it starts to action things? Probably not. They want to know that when you hit left click, it does something, and they can change what that left click does. So traits go hand in hand with what's called behaviors. And that's where all the design magic happens, and I'll go into that into more detail in a second. But what we were able to do as developers is specify different functionality sets, what it can do, how it does it, and then designers can go in and know that if they're making stuff for an actionable trait, they can make 3 actionable behaviors and just slap it on an X. And then they can take those behaviors and slap them on anything else they want to too. So very quickly, you can have something generic throw be applied to a donkey if you wanted to. It can be applied to your friend's corpse that you're trying to pull back to revive in a bed. It can be applied to a tree log if you want to start throwing sticks at people. It's really cool how some of the stuff that the developers started making straight away with this. So in more detail, traits are a macro definition of a functionality subset. It can be the data or the interface. So a trait could just be how moist you are, the moist trait. And it will just be a float value of 32. We can have a flammable trait, which is the same thing. How prone are you to being set on fire? How hot are you right now, and how close are you to being on fire? Or it could be like a complicated interface of different functionality and event hooks. Designers love little events that can click off, and they can put a nice bit of blueprint right there and just make sure that gets executed. Some of our traits have 6 or 7 different things you can bind to. And yeah, what's really key is programmers make traits, and traits don't have any knowledge of what they're actually going to do. They just know what to call and what their names are. Behaviors, as I said, is where the design magic happens. They can be generic or specific, so you can have generic melee one hand or Sean's breakdance throw, which he actually tried to make, where the dude would do a backflip and throw a knife, and it's pretty cool. You can extend them via blueprints, and that means design doesn't have to worry about dealing with C++. They can go, I want a new actionable behavior, and it'll just pop up with all the events already there for them to fill out, and they can just start doing their stuff immediately. It automatically binds itself into our system, so it's all automagical. They can create that thing, and it just starts working. And it's RPC compliant. Icarus is a multiplayer game, so all of our stuff had to also be able to be called across the network. And the last thing is it's reusable. As I said before, behaviors can get thrown all over the place. They can get reused for certain things. We made a grenade, and then all of a sudden we had anything could be a grenade. And then we made it grenades could explode in whatever payload you wanted. So we can make grenades that would explode into confetti or goats or lava. It was real. In fact, you can make a grenade explode into crafting benches if you wanted, already crafting some item. Obviously, that's not something we'll have in the game just yet, but maybe one day. I don't like bringing lots of code up into talks, but this is a snapshot of the piece that makes all the magic happen. And I think in Unreal Engine, you know when you're working with a system that is compliant with the engine, when it's a short, discrete use of their already existing work. So this is a bit techy, but for programmers working with Unreal Engine, you can fight the engine a lot. It's because it does so much for you and it does things in the way it wants to do it. If you don't first learn about how it wants to do things and exist in that space, you can start wrestling with it. And then all of a sudden, 3 weeks down the line, you're pulling your hair out and then you go, oh, I'll just do this. Unreal does it for me. And then 45 minutes later, your thing's working and it sucks. So when you are making these expansive systems, know that elegant code is usually what takes place with Unreal. People can get bogged down in its complexity thinking that you need to write complex code to make good systems with Unreal, but it doesn't have to be. It can usually be quite simple. Also, this is using the reflection system, which is all that macro magic Unreal does. First step for any developer working on Unreal Engine is get really familiar with that because it makes your life so easy. You can get access to pretty much anything. It's like magic, literally. So what I just described to you is still a spaghetti monster, right? We haven't solved the problem of like merging or having like clear information throughput for designers. Where do they find this stuff? And fairly quickly you'd be finding that on your plate and thinking like, oh, I've got to update engine, and then he's going to start attacking you. So our solution for that was data. And it's a very simple solution. People have been doing this for a long time. Developers, just through necessity, we like data tables now because it's an easy place for us to see everything. Unreal already has a lot of great data systems embedded in the engine already. There's data assets, there's data tables. And what we were able to do with this, combined with our great tools, is we could create this awesome presentation for the designer where they could see everything about an item in an immediate format. They could see exactly how flammable it was, what actions it had available to it, what mesh it was going to use, what its item description was, and all these wonderful data tables. And it meant that for the designer, it's really easy for them to navigate through an item's description. I'll admit it's not as easy as opening a single blueprint and seeing everything there on in the inspector window just there, but I was just talking about how those blow up. So this was our kind of great middle ground of how we can get things going. So what's awesome is maintainable, searchable, but even better for large games that are multiplayer based, you're going to need to take all that data and put it somewhere, and you're going to need to read from it, and you're going to have back-end stuff, and then you have to give it to people somehow really easily, and it just kind of plugged in. All of those problems got solved for us. How do we distribute new items to players? How do we create new skins and give them to players easily? How do we make value changes to our game without releasing 2 24 gigabyte updates? Arc, So it's really nice for us to be able to save all those things, and now they're mergeable. And the way it can do that is because data tables in UE4 export directly to JSON. JSON is an industry standard format, and it's like the easy way to describe an object without actually having to write any code. And on the left there, you can see our data table viewer. This is complicated JSON. This is what actions look like in data. It's not very interesting for anyone who isn't a programmer, but I think that's pretty cool. Like even just reading through that, you can see the top generic melee. It's got 3 actions. It's got some montages. Sweet. But we're not going to get people to read that. We're not even going to get people to read that. The default Unreal tool thing is kind of lame. So we had a tools engineer spend his entire time making this, which is our extension of the data table editor. So here you can see that same thing in the same format. This thing has a generic melee. It's got a montage it's going to play. It can have 3 variations of it, and the stamina action it gets called is do hit, and it's got a cooldown of 0.6 seconds. So at a glance, you can immediately see all the stuff that's going on here, and this is where I'd really stress these tools were made available by learning the reflection layer, learning how Unreal likes to present and transmit information in the engine, made it really easy for this tool to get created. People who've worked in Unity, like I spend a lot of time in Unity, you go to Unreal and you try to make tools, and you're like, dude, this sucks. It's really hard. Nothing works. But really, reading through their code and getting really familiar with that reflection system made this super, super easy to make. Having said that, Ryan still spends all his time working on this. And the other thing that's really cool, like I said before, is its back-end integration. And the most important thing for us now is that we can have a content server hosting all of our JSON, like literally everything that describes what the game can do in this JSON server. And then when a client logs into the game, they can get the latest version of that, and automatically they've got the latest patch. So if we make a patch that hasn't got anything to do with a new art content or new maps, but it's value changes, or say we've already got the art assets on their local machine because we packaged it early at the start of the month, we can make new items on the fly instantly. Like we don't even have to push through Steam to get that patch out. They'll be able to connect through the thing, pull it down, and bam, they got new stuff, which is super, super cool. So yeah, that in combination with a trait system is still not enough. We haven't quite got all of the harnessing yet, like what creates and collects all of these different things together, and for us, that's items. Items are a classic concept in games. Everyone makes items, and that's what makes most of your game. But we wanted to make sure that items could be pretty much anything. They were the collected harness. And I don't need to talk about this slide too much, but it just means that we have this concept that binds everything together. An item could be an axe in your hand. It could be a bench on the ground. It could be the floor in your building. It could even be the tree piece that's fallen on the ground in front of you. It just gives us an easy way to communicate all of our ideas and information through all of our designers. These are some examples of some of the items that we've made. Those are just cool icons. I just wanted to show them off. So here is a screenshot of a base that we've built with the trait system. So all of those pieces in there have their own traits, like the crafting bench will have its description of what it can do. It can get set on fire. You'll have the fireplace there that talks about how much heat it can put out. Each of those building pieces have conductivity, so if there's a lightning storm and you're standing next to a base, thankfully your base will get hit and you'll have to put it out, but you won't get struck. Same way that if you're standing in a forest, everything kind of helps diffuse that threat of getting struck by lightning. You can set everything on fire now, as I said before. Our programmer made a really cool fire system that just used traits to be able to propagate temperature throughout the forest. It took him 2 weeks to get all of the, technical throughput ready for making the visual system work well, so we could do this without blowing up our frame rate. But the idea and the simulation of fire spreading was done really easily with the trait system. And now you can set everything on fire. Literally everything can get set on fire. Anyone who's seen some of our streams last week, there was a base building contest, and what they did is they jumped in campfires, set themselves on fire, and ran into their bases, and all of a sudden, everything sucked. It also enables awesome things like storm and lightning that I was talking about before, but also like wet, setting things how wet they are, like having these great environmental simulations, these huge networks of things. And it all came from Dean coming in and saying, I want storms to matter. I want them to hurt people. I want it to be terrifying. I want it to be scary. And it's good enough. It's all well and good to have audio and special effects and things make that happen. But it's really great when you know that a lightning is going to hit your base, set it on fire. You're going to have to run around and pat everything down. Meanwhile, there's a hailstorm hurting you, and then a bear attacks, and you're like, man, I just want to make iron weapons. And so it was a great tool for being able to introduce those complicated systems. And the last thing is, through all of this chaos, we can kind of get together to create this, what's the word, like harmony within our game. Everything is really easy for us to provide that insight and input without having to worry about a huge interconnected webwork of stuff. Our designers seemingly think it's pretty good. I asked them briefly before I came here. I was like, hey, what are your thoughts on the trait system? And one of them went, that's fine. And then the other one said it's probably one of the best tools he's been able to work with so far. And I know it really helps for us in our production as well. And it's just kind of like a super powerful tool for our use at RocketWerkz. I guess my talk's pretty short, but I wanted to leave a lot of space for Q&A, because normally when I talk about this stuff, questions come through, and I like to talk on for hours, and that's how my lectures used to work. But we do have a Discord. Please join it, SurvivorChris Discord. Wishlisted on Steam if you want to. That's all really cool. Also, come work for us. We want to expand our team. Please, if there isn't a particular role that's up there, set out a point of interest if you'd want to come work with awesome systems. I can speak personally that the studio has an atmosphere of wanting to enable work as best as possible. The trait system is just one of our many systems we've created as a tech team and processes to enable the best content that we can make. We've turned Icarus into a product that I'm super proud of in a very short space of time, and it's because of our ability to front load all of that work. We took care to make sure that when we were in crunch, or well, we don't want to crunch, but when we are getting close to our releases, when we do have a content cadence, that we're not fighting each other. We're not worried about hurting each other or arguing around technical practice. We just wanted that to happen easily. And it meant that our studio atmosphere now is really collaborative. We don't get scared about coming up with interesting ideas. Our design team can do that brain to game all the time. They don't look at the programming team with anger. It's just a really nice relationship, and it helps us create a really warm studio atmosphere, because every voice can now have more value because there isn't as much overhead to trying to get that voice and enact the dream or the vision or whatever they bring up. When you've got harder systems to deal with, and someone's like, hey, why don't we do this? Everyone goes, yeah. It's way cooler when someone can say, what if we do this as a trait? And then we go, actually, that's a fantastic idea. Let's trial it. It'll take us 2 hours to put it in game and see how it works. The work, of course, comes when you have a bunch of items. If you add a new trait and you want something to do it, you need to add that data to all of the items. If you want something to be conductive, and if you want everything to be conductive or everything to get set on fire, you need to do a design pass. But that's just the nature of the beast, I think. And we've come up with the best way to make that information more available and more readable for our designers. Yeah, that's my talk.
Thank you.
So we are doing a Q&A. Feel free to fire your questions through on Twitter if you have them. In the meantime, we were chatting just before this about the production processes that RocketWerkz uses. What are your production processes like between design and programming?
That's a great question. So because we have this really common design language now with traits and abilities and all that, we can kind of sit down and a designer can say, okay, we want to do quests, or we want to do storms. And we do a kickoff meeting with design and programming. We'll probably elect one developer who's done stuff similar to that before. They'll sit in the meeting, and design will talk about what they would like to add to the game from a motive language sense. So they'll say, we want to provide threat to the player this way, and we think we can do it with these values and these mechanics. And the programmer is going to sit there and go, okay, I think that's a trait, or I think that works in with this system. And then from that, we can scope out the work, and it kind of iterates really quickly like that. We do 2-week content pushes at the moment, where we'll play the game, get a bunch of feedback, and then try and establish what it's missing and lacking, and that'll result in those kickoff meetings. And then those kickoff meetings will come through in a short period, and we'll do a review, and over and over and over. So yeah, it's made that really stress-free for us. I actually find those kickoff meetings super exciting, especially when you have a kickoff meeting, and then like an hour later, you walk past someone's computer, and you're like, oh, that's the thing. Awesome.
It's real. It all comes back to that collaboration that you were talking about from the sounds of it. Nothing happening in silo.
Exactly. Yeah. And encouraging that conversation is awesome.
Absolutely. You mentioned at the start of your talk the Unreal Engine digital humans, which are a really fascinating product. What about them specifically has got you excited about them?
I just think it's to enable content like that's kind of cool. I think talking about the stereotypes talk that was earlier today, which was awesome, by the way. I really liked that talk. Being able to enable creators to create better representations, more accurate representations, better looking representations, and then have that be an easy workflow means that if you do have, say, the greedfall issue and you say, hey, we'd like to change all this, if it's easy to do that, it's even easier to justify it. It's even easier to convince them to make better representations of those things. And because I worked with digital people for so long, just seeing that tech is super cool. We're getting closer to the oasis. I'm just really excited about it. And it's just neat to be able to do that. Yeah.
It really is. With any kind of smaller team as well, having high-end tools available for you to use makes your work that much more high-spec with so much less effort on your own part too.
Totally. And that, like I was saying, democratization of technical gameplay, technical systems means that anyone can make cool stuff. Now, obviously, there's a lot of overhead. Technical systems require expertise to make look really good, but more than ever, we're enabled now to make interesting content. And I think we sometimes get caught up with having all these wonderful, fancy systems, so we try and make everything wonderful and fancy when, we've played plenty of games where, it doesn't need to look incredibly awesome. I mean, Undertale has great aesthetic, but it didn't need, super realistic humans to make that game wonderful and enjoyable. But if you do want to make something that's like a LA Noire type game, if you've got some friends, you might actually be able to do it now. Yeah.
Well, say that I've been using those fancy pants systems and maybe not known what I was doing and created a spaghetti monster that I haven't noticed until very late in the process. What's the best approach I can take to slaying that beast and getting things back on track?
Nice. I think the best way to do it is to quickly identify what you're doing a lot of. So in lots of Blueprint is a problem where people will make like a little node thing and they'll be like, oh, that does something cool, and they'll start copying and pasting it everywhere, or they'll start using a bunch of different places. Identifying those reusable pieces and then making like good abstracted kind of blueprint architecture to make that little piece a node, and then that node can get called everywhere, and then you can call, just similar to programming techniques. It's about taking all of that spaghetti and putting it into straight lines, and then sorting it, and then moving it out, and then all of a sudden you've got a nice spaghetti highway, and everyone's really happy with how your stuff works now.
So in other words, I need to find a digital comb.
Yeah, exactly.
Comb my spaghetti straight.
100%. Get out the ticks as well, and be like, ooh.
There's a comment that's come through on Twitter. It's such a fantastic way to use JSON data to describe relationships in code. Is there anything you'd want to say to much smaller teams who want to implement similar systems?
Oh, absolutely. I think we created this system for a large team. We knew there was going to be huge throughput. We're going to have a lot of developers trying to work in parallel. So a lot of the complexity around our system came from that, that necessity. For smaller teams, if you just want to have like really great data workflow tooling, I think the best tip I can have is try and get into data as early as possible, and you don't need to make all the fancy editors if you're in a small team. With small teams, you have more little workflow issues you can't solve, and that's just kind of the sacrifice you have to make. But focusing on that data early means that you can start to, what's the word I'm looking for? Solve problems that way. So I was working on a system like literally 2 weeks ago, and I was like, how do I do this? And one of the senior devs rolls over, he's like, you should turn that into data. I'm like, oh yeah, I can turn that into data. And I was like, oh, I can turn that into data. And then all of a sudden everything's in data and it's super easy to use now and the system just was way better for it. So the sooner you start thinking in that way, the easier it is to make decisions in that space and the faster it grows.
Starting from the ground up.
Yep.
Solid foundation. So another question that's come through here. It's very cool to hear your talk on traits, especially since thanks Jeff, designed essentially the same system for my games. How do you incorporate very unique behaviors, for example, the behavior that for something that isn't reused anywhere else?
Awesome, yeah, and that's a great point as well. When we have those kickoff meetings, we'll identify if what we're trying to create it does need to be reusable or if it's a unique one-off thing. Through that system, because what we were able to do is find a way to bind blueprint objects in any way to these traits, we can create quite complicated ones, and if they're so complicated that they just need to be an actor or something very specific, we just let that happen. We just say, cool, don't worry about using traits, you've got an item and the item uses this item actor class, and it kind of overrides the rest of the thing. So it allows us for designers who don't want to have to go through the whole system to get something super reusable and working, they can just make an actor. So the last thing we wanted to do was stop people from doing that. We just wanted to encourage that they did it only when they needed to or when it was easy to. In fact, a lot of our prototypes start as those simple actors, those whole objects, and then get broken down into traits if they need to be. So it gives us that ability to kind of filter it down.
So that's quite cool. So you're able to almost work backwards if you realize that actually something is bigger than you knew it was going to be. There's the theme. Then you're able to work it backwards.
I totally planned that. Like that was all, yep.
That's very cool. There's a question that's come in from the NZGDA. As someone who didn't get to learn Unreal at university, what resources or recommendations do you have for coders who are trying to self-teach themselves Unreal?
Awesome. Not my textbook. It's way out of date. Yeah, I apologize to anyone who picks it up in today's age. But the Unreal documentation used to be kind of average, but it's grown so much now. I'd recommend going through the programming tutorials on the website there. And then also there's a bunch of great YouTube channels. There's this one, I'm so sorry, I forgot the YouTube channel's name, but it just says, what is this? And it's in big, black, bold letters on a white background, and it talks about all the different systems that are on Unreal. So yeah, those videos, the documentation, and the Unreal, Unreal hosted educational content is really good now too. Yeah, it's definitely come a long way from the original days where you open up the docs and go, nothing's here. And you just kind of like start digging through the code and cry.
I imagine they're pretty enthusiastic these days for people to be able to use their product, and so having supporting documentation on how to use it is a win-win for everyone. Totally. On the topic of systems and tools, what's your favorite internal UE4 tool, like the animation system, audio cues, that kind of thing?
Great question. I mean, I think Niagara is awesome because I like doing fun. I mean, like my originals bio that I sent here was like I wanted to be a tech artist / designer and found myself in this tech lead role instead. So anything that kind of enables that cool stuff is really awesome. The control rig stuff is also really cool. Like if you want to make a crocodile tentacle monster and you need all the tentacles and tail to not be animated because that would make your animators stab you, you can basically do that all through control rig now, which lets us add a little bit of programmer magic to animation as well. So any of that stuff that adds that nice little extra bit of fidelity or funness is pretty sweet.
I love that. It's the creative elements coming into I mean, not that programming's not creative in the first place, but the creativity that the people on the end can see. It's really cool.
Totally.
When you're developing how do you determine the appropriate time to spend on a tool, considering team size and scope?
That is an awesome question. So I think what we did is we prioritized our tool based on how much they'll be used. So like, in the idea of our data table system, every single person was going to be using that data table editor. Programmers, designers, artists, audio people, even our content creator, our community manager could use it, use that stuff to create new content, like custom skins for streamers and stuff. That can all go through that system. So that got maximum priority and top thing. Then we would look at roadblocks. What are we having troubles with? So if anyone has done a lot of big open world stuff in Unreal, World Creator can be a bit of a challenge, a bit of an issue. And so creating tooling that supports world creators was also really important because they were struggling and having a lot of merge issues and compatibility stuff to make that better. And so when we ran out of things that we knew everyone was going to use and stuff that was slowing us down, thankfully our tools engineer is really passionate about making tools. And a lot of the time he'd just rock up and be like, hey, I think this would be really good. And everyone around them goes, yeah, Ryan, do that. In lieu of that, it's just, I think watching people work is really good. I like extreme programming a lot. I like going and not even necessarily extreme programming, but watching world builders work, watching designers work. And just through that process, you can kind of see how they're interacting with the tools, and you can see what's causing them issues and problems. I find when people are wrapped up in their work, they have a hard time of actually communicating what's slowing down their processes, what's stopping brain to game. But you can quite easily identify it if you watch someone for a couple minutes. Obviously, don't be like, hi, but just sit down and start talking about their process and have a little a chat, and then before you know it, you'll be like, oh man, this would be really good. So yeah.
It's that classic thing where people don't know what they don't know. They don't actually know that it's a problem because they don't know it's a problem that could be solved. They thought it's just part of the normal thing.
Totally. And people using tools as well, if something doesn't quite work, they'll just subconsciously make a little workaround, and they'll be their process. And they'll be like, oh yeah, I just have to copy paste this and put it over here. And the tools engineer would see that and go, you're using it so poorly. I'm so sorry. And then the person's like, it's fine, man. It's like 20 seconds. But yeah, it's one of those things.
Yeah. At 20 seconds, though, like if it's happening 20 times a day, it starts raking up.
Yep, exactly.
There's another question here. What made you choose Unreal over other game engines?
So Unreal for us was, I think, because of the size and the quality fidelity wanted to hit, and we had a lot of great developer experience. I'd written a textbook and spent most of my development time in Unreal. But it was just kind of like a natural fit for the project. And thankfully, because Fortnite is a thing, Unreal puts a lot of effort and time into open worlds kind of survival-y mechanics. That's where, gas comes from a lot of that as well. And there's a lot of kind of technology throughput coming that way. So we see this Battle Royale game founded on survival basis, and then this influencing Unreal Engine technology. And we were like, all right. And it's definitely helped. Like that decision's been perfect for us. So yeah. I don't recommend Unreal for every project. That's something that, obviously I love it, and hopefully everyone would like to use it more, but it really comes down to what you're making. If you feel like you're going to be wrestling with the systems a lot just to get, say, like a cool top-down 2D RTS game, then maybe you look at doing your own thing. In fact, it's interesting. We've got another secret project in the studio. That's Dean's little, passion thing on the side now. He made that in Unity, but constantly talks about how he doesn't even really need Unity anymore. That game was simple enough that he could have kind of just gotten a third-party renderer and just plugged his stuff on top. So, when approaching that stuff, really think about what you're going to use. And if you don't know what you're going to use, then the worst that could happen is you have to have a couple headaches that you didn't need. But it's, Unity, Unreal, they're going to really help you through.
That classic thing is everybody loves a race car. You don't necessarily need a race car to drive to the supermarket, though.
Exactly, yeah. Yep. And that's one problem we've had at RocketWerkz with this whole trait system is sometimes we'll be like, hey, we need this thing, and then someone comes back with a Ferrari, and you're like, I wanted a shopping cart, but this is a great Ferrari, I'm super stoked now.
Actually, on that note, have you ever had to say to a designer, that's not possible, you can't have your Ferrari? And if so, what's been the blocker?
Great question. Yes, I think sometimes earlier on when we more or less have about time constraint, like a lot of the things we say is not right now. And that's because we haven't yet encountered, thankfully our designers are quite good. One of our designers was a programmer in past, and another one was a technical designer working on crisis games. So a lot of our design front right now does come from a fairly tech background. So I want them to do the opposite. I want them to push the boundaries until we say no, because they usually come forward with quite reserved concepts, and we're like, no, pump it this way. Dean, on the other hand, I've definitely said to Dean, hey man, that's going to be a bit too much, but he's super pragmatic and really good about, if we say that's a bit out of scope or whatever, he's like, awesome. And then now, to be honest, even that was a year ago, now Dean's even better, really good at making sure we keep things in an achievable scope. Again, when you create someone the ability to make all these wonderful things, people want to do it. People want to make great stuff, and sometimes you just have to ship, or you have to push towards release, and that means kind of, settling down a touch. Yeah,
the big dreams are exciting, but also so is making the deadline.
Yeah.
Also pretty exciting.
Exactly.
A question specifically about Icarus. Do you need to scan over all objects in an area to determine where the lightning will strike? Same for the fire spreading?
Not necessarily. So I think what we do, sometimes, for scalability reasons, we'll do localized areas of concern. So a fire is only concerned with the things directly around it, because that's the only thing it can set on fire. Similar with lightning, we'll be like, cool, there's a storm. We know where the players are, so we can create a general area of interest for that storm, and then we can start querying around that space. Because we have, distant lightning, and we've got lightning that hits near the players and stuff, and that's all just kind of, I guess, if lightning is doing cool stuff but no players around to see it, is it a game feature? That kind of thing. We do want to create that natural feeling world, but games are an interactive experience for the player, and so yeah, we just do it around them. So that helps us kind of scale that stuff back a lot.
Yeah, I can imagine it would make it a lot more manageable. We heard from Philip yesterday on the difficulty of adding long-term content after launch, and given that Icarus is being designed so that it will have more content added over the years, how are you tailoring your approach to make that a smoother process?
Awesome, that's a great question as well. So we've actually got, thanks to one of the design pillars, which is that kind of split between space and planet, we have this great sessionization of survival gameplay, which means that when you start a new session, you can have access to any of the new content we've put in pretty much immediately. So, big monolithic games that have persistent world maps and things, they've got to keep touching stuff on the end. MMOs are a great example, right? Like, I've played a lot of World of Warcraft, way more than I should have. But every time an expansion comes out, they just kind of put it at the end, and then you go through the other content faster and get to the end bit. With sessionizing it, we can kind of have this content injected immediately. We can make the early game way better kind of just straight away, because you'll start a new session and be like, oh, cool, here's all these great improvements they made. And so for long-term interesting content, we kind of look at how players are going to interact with the game and make assumptions now. We're then going to make assumptions when we see how players are interacting with the content and if it aligns with our current plans. And we've got great grand plans for what we can start putting into the game. As an example, if we wanted to add vehicles to Icarus in a big way, like we wanted flying vehicles or tanks or whatever crazy like that, we could go, cool, now they're available, you can build them now. You don't have to break down your whole base and retool everything. Like, you can just start a new session and then work your way towards it and start playing with it. And similarly, if we want to make new map content and things, we can just have them land in a different place in the map. We can have them move to new areas. Unlike, say, DayZ as an example, if you've got this huge map and you put a bit over here, people have to go, all the way through to the new place. So yeah, that helps us plan and scale that long-term content. But it's all that crazy pie-in-the-sky stuff for long-term. You always go, cool, for this, we're going to do this. And then we start to realize you actually do this, and then you do this. But this is still really cool. This still ends up being this great hardened diamond. You've got all of this amorphous potential, and then what comes out is usually something quite awesome.
It's a really clever approach to making it it's more streamlined. It's a good way to describe it. We've got one last question for you, which is just a little bit of a fun one. As a tall person in a desk job, do you have any advice for people with back problems?
Oh, yeah. Absolutely. So I think we were talking about this briefly as well around like fitness and stuff. I think, people see fitness and doing exercise as the way to solve back pain. And it is, but it doesn't need to be the grunting, sweaty, like, gym heavy stuff. That's awesome, I love that stuff. But the key thing is, doing a bit of a stretch. Yoga's really helpful. Like, even just checking out Yoga with Adrienne on YouTube, she's got some good, some good claps. She's got some good, little 5-minute and 10-minute routines that can really help you just kind of limber things up and stretch. Going for walks really helps. What I found personally, doing the yoga stretching and then the disc golf thing has sorted the back pain out. So, and also even just like walking for lunch helps a lot. So do a bit of a stretch, go for a walk, come back, and that's sweet. So yeah, flexibility is so key. It's weird. And also flexibility also strengthens muscles at the same time when you do the yoga stuff. So yeah, it's pretty awesome.
Win-win.
Yeah, yoga.
Amazing. Thank you so much for your time, Ben, and for your insights. This has been awesome. I think we should give him a round of applause.
Thank you. Cheers. That's fun. Who do I give this to?
This way, I think. So we're going to break for lunch now.